So, good day, everyone. We are the Math 100 Group 2, and we are tackle about the pie or circle graph. So, I am your leader, Joshua Rotaboada, and these are my members, Nika Tordios, Dina Abegar, Mera Lizel Minyao, Raiselin Abelo, Lovely Nilas, Adrian Anyasco, Cindy Kimki, Corina Ortega, uh, and Mary Luz, Arcelon, and John Ryan Manuel. So, so next we will tackle about the topic introduction, which will tackle about Nika Tordios.
So, good day everyone. I'm Nika Sitorges. The side topic that I'm going to discuss today is about the introduction of pie or circle graph. So, what is pie graph? Pie graph is used to show the relation of the parts to the whole and to each other. There is no chart or existence as misunderstood, detested, defended, and talked about than the pie chart. How can a chart that resembles a much-loved dessert be so polarizing? Well, pie charts get a bad represent because they are often used to visualize data that could be much better served with a different chart type. Plus, some people don't know how to use pie chart or graph effectively. If we are going to choose if we choose to build a pie chart or graph, there are a lot of ways that it can go wrong. But simplicity is the key. There is nothing worse than a pie chart with too many slices or categories in another terms that make it impossible to compare. When it comes to a great pie chart, simplicity is the key. Don't include more than 5 to 6 categories. And most importantly, make sure that your numbers add up to 100%. So not doing the math correctly is a common mistake that makes your pie chart useless. Pie charts or graphs are designed to show parts of a whole. So any sum below or above 100% doesn't represent the entire picture. Pie charts are great if one or two of the categories or slices have a much higher value than the others. This means at a glance, it's easy to see which categories have the largest share of the pie. If all the pie slices are roughly the same size, it doesn't tell a good story. Pick a topic to visualize that is broken down into more than 5 to 6 categories. As what I have said a while ago, simplicity is the key. Don't include more than 5 to 6 categories.
So the objectives of Biograph. By the way, I am Marilizal now, and I will be tackling about the objectives of Biograph. So the first objective is to visualize information and data. So the pie graph, one of its objectives is to show information and data gathered, for example, in a research. The next is to easily show the results of an investigation in a proportional manner. So when we say proportional manner, it is to arrange the information or inputs in a manner that can be easily understood. Next is to show the relationship of each part to a whole data. So for example, in a 100% pie graph, 20% are children, 45% are men, and 35% are women. Then the third one is to provide a better data intensity ratio. And it is to break down a ratio, for example, in a research. This graph is used to clarify how many or what percent does a certain data hold in a whole pie graph. Then the fourth is to illustrate numerical proportion. So one of the objectives also of a pie graph is to present a numerical data that was gathered. For example, in the pie, 252.5% on 2005, 250.25% this year,
So continue, Miss Abaigar.
Okay, so next slide po. So the objectives of a pie graph is to represent a part-to-whole relationship of data, to display statistical information, and to compare each group contribution to the whole, to summarize a large data set in visual form. So for example, in a pie is divided siya. So pila ka slices in every slices na ay naka-indicate na percentage. So like for example, we have 40%, 30%, hangtod sa ma-equal siya in 200%. Unlike i-compare nato siya sa line graph kay like line graph or bar graph, naa siya changes over time. Unlike the pie graph, complete na jud siya. So it is the easiest way to identify the differences among the every group in the pie chart. Next to present, thank you. So to easily visualize concept that other types of graph. So as what I've said, it is the easiest way to identify the differences of the percentage in a whole graph, in a whole pie graph.
history of pie graph. So the pie graph or chart has been around for over 200 years. It was first invented in 1801 by Scottish writer and political economist William Playfair, born in 1759 to 1823, nowadays known as the inventor of statistical graphs. So the discovery of pie graph started 200 years ago by William Playfair. At the time, Playfair believed making an appeal to the eye when proportion and magnitude are concerned. It is the best and readiest method of conveying a distinct idea. And the pie chart and bar chart were born. Some people believe that he also invented the line chart, but that story is better left for another time. His first notable use of the pie chart was to compare geopolitical territories represented by circles, sometimes segmented in slices, like in the case of the Turkish Empire, second circle from the left. The invention was almost forgotten until 1858 when a French civil engineer Charles Joseph Minard created a divided circle map. So the divided circle map was the picture above. You can see showing the amounts and proportion of butcher's meat supplied to the Paris market. So if you want to learn more about Minard's influence in data visualization from central regions, you can search it on the internet. So the picture below is an example of the modern use of pie charts. So as the time evolves, the modernization of pie graph exists. Here is an example of a modern use of the pie chart used to display sales by region. As can be seen, the basic principles have not changed in over 200 years. A circle is divided into segments where each segment represents one piece of data. So which means pie graph represents a part to a whole. Each segment's angle is proportional to the value of the piece of data. So this is the pie chart which is equivalent to 100%. So each part or segment is divided and each segment must be equal to 100%. Up next is terms and definition, which is to be discussed by Adrian and Yasco. Please proceed. So terms and definition refers to the terms or words being used in our reporting. So these are the words. The first one is pie graph, which is our topic. So a pie graph or a pie chart, or also known as a circle chart, is a circular statistical graphic which is divided into slices to illustrate numerical proportion. Next is proportion, a part, share, or number considered in comparative relation to a whole. Statistical data, the mathematical science dealing with the collection, analysis, and interpretation of numerical data using the theory of probability, especially with methods for drawing inferences about characteristics of a population from examination of a random sample. So the rest will be continued by Adrian and Yasco.
Sorry for the there is a technical problem with my connection. So I'll continue to the objectives, right? Um, so the objectives is a mathematical equation that describes the production output target that corresponds to the maximization of profits concerning production. The next is the amount. The sum total of two or more quantities or sum aggregate. And the last, I will give the stage to Miss Lovely Nilian since she is my actually partner with terms and definitions since we are assigned to this topic.
The last one is data. Collection of facts such as numbers, words, measurements, observation, or event, just description of things. That's all. Thank you. Today.
So the next
Convert.
slide is
Oh.
convert. A collection of facts such as numbers, words, measurements, observations, or even just description of things. Next is percentage. Percentage or percent simply means per hundred, and the symbol used to express percentage is this. Next is nominal data. Labeled or named data which can be divided into various groups that do not overlap. Data is measured or evaluated in this case, it is just assigned to multiple groups. Okay, Miss Lovely Nilas, can you?
The next one is illustration. The use of examples to make ideas more concrete and to make generalization for more specific and detailed. Next is visualize the ability to see and understand a problem situation. Visualizing a situation or an object involves mentally manipulating various alternatives for solving a problem related to a situation or object without the benefit of constraint manipulative MOE 2001 P 51.
Thank you. And we will give the stage to the next presenter or next topic.
So, hello, I'm Karina Ortega. Well, here are the following steps and processes on how to create a pie graph. The first thing you'd have to do is to organize the data that you have gathered rather. Then next is to convert each amount into percent. So in order to do so, you'd have to multiply the data that you have into 100 to get the percentage. The next thing is to compute the number of degrees per item. So in order to get the degree of a number, you'd have to multiply it to the measurement of the shape that you have. So since we are talking about a pie graph, you'd have to multiply it to 360 since the measurement of a pie chart is 360 degrees. Then next is to construct the pie graph. And then lastly is to, well, you'd have to write the title for your pie graph. So just a tip, please do use a protractor and compass so you'd be able to achieve a perfect pie graph. So to continue the discussion, may I please introduce to you Ms. Cindy Quinte.
Thank you, Ms. Karina. So today I'm going to show you the example and illustration of the pie graph. So this is the step one, organize the data. So here what has happened. So expenses. So we have here expenses, food, light and water, transportation, miscellaneous. So the amount of this each is food is 1,500 pesos, light and water 600 pesos, transportation 300 pesos, miscellaneous is 600 pesos. So this is the amount of the expenses. So a total of 3,000 pesos. So we have here the percent. So if you're wondering how did I get this percent? Well, I used the total. So the total will be serve as our divisor. So we're going to divide. So here, this is our dividend, the 1,500 pesos. So to get the answer, the quotient, so the quotient will be the 50%. Next is the 20, no, next is the 600. So we will get the percent of this. So 3,000 divided by 600 pesos. So the quotient will be 20%. Next is 3,000 divided by 300 pesos. So the quotient will be 10%. Next is 300,000 divided by 600. So the quotient will be 20%. So overall, it is 100%. So we have here the degrees. So if you're wondering how did I get these degrees, so here it is. 360. So we will going to multiply by percent, but we cannot do that if we will not convert this into decimal. So 50% is we will going to convert this into decimal, so it will be 0.50%. So 360 times 0.50, so it will be 180. Next is 360 multiplied by 0.20%, so it will be 72 degrees. So next is 360 times 0.10 will be 36 degrees. Next is 360 times 0.20%, so it will be 72 degrees. So a total of 360 degrees. So next is, so here it is, the example of pie graph. So I have question here. So which item has the biggest allocation?
Food.
It is obviously the food.
Yes, correct. So next is, which item has the least allocation?
Like transport.
Transportation.
Okay, very good. Next is, what percent is spent for light and water?
20%.
20%.
Okay, next is, which items have the same amount of allocation?
Miscellaneous and light and
Miscellaneous
water.
and light and water.
Okay, very good. So the last will be, how much is spent for transportation?
10%.
10%.
10%.
No. So that's all. So I'm going to give you to Miss Abelio. So it's your turn, girl.
Thank you. So I am Rosalyn Abelio, and I am going to discuss the sample problem. The pie chart below shows the percentages of types of transportation used by 800 students in going to school. The principal of the school wants to know the answer to the following questions. So this would be the basis for the pie graph. A. How many students in the school use bicycle? B. How many students do not walk? Letter C. How many students come to school by riding a bus or car? So note, the total of the percentages must be 100%. So you can see the pie graph in the left corner, and then I have to discuss the solution or the method why I get the answers. A. So the question is how many students in the school use bicycle? So as we can see in the figure, the percentages of students using bicycle is 45%. So you have to multiply 45% by the number of students in a school, which is 800. So when you multiply, the result will be 36,000. Since 45 is a percentage, you have to move two decimal places, and 36,000 will result to 360. So there are 360 students who go to school using bicycle. So letter B, how many students do not walk? So as we can see in the figure, the students who walks to school is 15%. So you have to subtract 15% from 100 because percentage means per 100, right? So it means 100%. So you have to multiply the percentages of students who walk by 100. So 100% minus 15% is 85%. Then 85% will be multiplied to the number of students in the school, which is 800. So if you multiply, the result will be 68. 68,000. So again, since 15% is a decimal, or we are going to find the percentages, so we are going to move two decimal places, and the result will be 680. There are 680 students who do not walk in going to school. And the last question is, how many students come to school by riding a bus or car? So in this situation, we are going to find the percentages of students who rides a car or a bus. So the first step is to add the percentages of students who use car and the students who use bus. So 30% plus 10% is 40%. So after that, you have to multiply 40% to the number of students in the school, which is 800. Then after that, you will get the 32,000. Then again, you have to move two decimal places, and this will result to 320. So all in all, there are 320 students who go to school by riding a bus or a car. So as you can see, the pie graph shows the distributed percentages in which you can see that students who use car is 10%, students who use bicycle is 45%, students who rides bus is 30%, and students who prefers walking is 15%.
So, hello again, guys. So, I'll be discussing the example number 2 of the circle or pie graph. A clothing merchant has 3,840 pieces of clothing of 5 types: the dresses, the skirts, the pants, the shirts, and the t-shirts. The pie chart below represents what fraction of the clothing are of each type. PQ is the diameter of the circle on the pie chart. So the PQ means the half of the circle. So the question here is, how many shirts does the clothing merchant have? So the question here is, how many shirts does the clothing merchant have? So we have to solve this. The PQ, which means the half of the circle, minus the 3/8 of the t-shirts is equals to 4 minus 3 over 8 is equals to 1/8. So this is the 1/8, but this is not the final answer. But we have to multiply the 3,840 pieces of clothing of 5 types. So 1/8 times 3,840 is equals to 480. So the clothing merchant has 480 shirts. So the next topic tackle about is tackle about by Mary Luz Arcelon and John Ryan Manuel.
Good evening, everyone. My name is John Ryan Chua Manuel.
Carlos Arcelon.
Our topic for today is all about generalization and conclusion of pie graph. Like bar graph, line graph, and other data displays, circle graph is a visual representation of data. In particular, a circle graph are used to show the relationship between the whole and its parts. The whole might be a total number of people or items. It can also be decimals that add up to 1. Decimals are related to percentage. They are both parts of a whole. A circle graph will often show percent that add up to 100%.
Each percentage is a part of a whole. The whole class or 100% of the students. The largest group would have the greatest percentage. In this case, carrot is the most popular vegetables with 46% of the first-year College of Education have. The smallest group would have the smallest percentage in this case. Two groups are the smallest or the less popular vegetables and fruits. In this circle graph, watermelon and mango are the smallest groups. Since this is a graph about popularity, you can say that the less popular vegetable and fruits are watermelon and mango. The most popular is the carrots.
As you can see, we have here the circle graph. So the most popular is a carrot. As you can see here, the carrot has 46%, and the smallest group is a watermelon and mango. As you can see here, the watermelon have a 7%, and also the mango had 8%. That's all. Thank you.
So again, I'm Nika Torres. So next, my assigned topic is about application of the pie group. So pie group it can be used to show percentage of a whole and represents percentage at a set point in time. Unlike bar graphs or line graphs, pie graph did not show changes over time. Pie graph is sometimes called as a circle chart, but don't get confused because they are the same. It is a way of summarizing a set of nominal data or displaying the different values of a given variable. Example is percentage distribution. So it is divided up into segments which each represent a value. A pie graph is a type of graph in which a circle is divided into sectors that each represents a proportion of the whole. It is useful way to organize data in order to see the size of components relative to the whole, and are particularly good at showing percentage or proportional data. So in pie chart, we don't actually need too many slices or categories, another term. In our pie chart or graph, we just need to make sure that the pie has a clear message, and our slices or our categories need to add up to an even 100%. And to avoid clutter, we must label the pie slices directly. So a pie chart shows the relations of parts to the whole for a variable. Pie charts or graph can help us to understand the parts to a whole relationship. Pie charts are often used in other situations, even if bar charts or line graphs might be a better choice. Pie charts are used for nominal or categorical data. Nominal data means it is labeled or named data which can be divided into various groups that do not overlap. While the categorical data, it is from a statistical sample and breaks them down by group, showing the percentage of individuals that fall into each other. Show so pie graphs, it is to show the percentage as a whole, represents percentage at a set point in time. Pie graph should be to compare each group's contribution to the whole. And lastly, pie graphs, it is the entire circle represented 100% of the data, and each sector represents a percent of the total. That's all. Thank you.